Welcome to the Imagine Conference. I am very excited to talk to you about the work Arizona State University Cloud Innovation Center did to improve student learning abilities. Effect of carbon dioxide on the human brain has been the topic of several research studies. There is evidence that indoor CO2 has a negative effect on test scores and learning abilities. Research points to effects of carbon dioxide on cognitive function and decision-making abilities. Researchers at the University of Colorado say the rise in CO2 can affect the ability of people to think critically. Professor Joseph Allen of Harvard School of Public Health measured a 15% low cognitive ability score at 950 parts per million and a further 50% decline at 1,400 parts per million. Arizona State University engaged the ASU Cloud Innovation Center to identify and develop a solution that would enable ASU to monitor its classrooms for higher levels of carbon dioxide. Our solution approach involves collecting data from the indoor environmental sensor. The environment data is continuously being monitored real-time. An alert is generated if the measured value breaches a pre-specified threshold value that is determined to be harmful and will affect the student's ability to learn effectively. The alerts could be consumed via text messages, real-time chat bots, real-time dashboards, or even operate an actuator to improve the ventilation of the classroom. Smart cities have the mission to deliver a good quality of life for their residents while facing growing and complex environmental, economic, and social challenges. Data is critical to gain insights that help optimize hard and soft infrastructure and build and operate efficient and sustainable services. The Smart Territory Framework, or sometimes referred to as STF, is a set of tools and standardized modules that our partners and customers can assemble together to build and operate sustainable and highly effective solutions, in line with global industry standards and based on the open-source offering of the FiWare ecosystem. Here is a high-level overview of the solution architecture. Step 1. Let's start with the sensor that monitors the environment. We used MileSight Indoor Environment Sensor to monitor the carbon dioxide levels. Step 2. MileSight Indoor Environment Sensor captures environment data and communicates with the LoRaWAN gateway. LoRaWAN stands for Long Range Wide Area Network. Step 3. LoRaWAN Gateway uses AWS IoT Core for LoRaWAN to ingest data into the STF Core engine after it's been validated by IoT Rule Engine and transformed by AWS Lambda Data Modeling Adapter. The Smart Territory Framework, or the STF Core Stack, provides a unified API that exposes two services. One of them is the NGSILD FiWare API to interact with the FiWare Context Broker. The other one is the STF IoT API to provision and manage your things in the STF IoT registry. Finally, the STF consumer consumes the data from STF Core. In our case, Athena is used to query STF IoT Data Lake. AWS IoT Twin Maker provides a unified data access API to read from and write to the digital twins source data. Amazon Managed Grafana is leveraged to build a dashboard and expose the scene from Twin Maker via the dashboard for consumption by the customer. Here is an overview of the customer dashboard and how it will look like. You can see the graphs that show the trending of the monitored environment variables over a period of time, and that includes carbon dioxide, temperature, and humidity. Also, on the bottom left corner you can see a sample 3D view of an Arizona State University classroom that turns its color to green or red depending on the threshold value of the monitored environmental parameter. Thank you for listening, and please feel free to visit the Arizona State University Cloud Innovation Center website shown on the screen, or contact one of us and we will be more than happy to assist you. Nice to meet you. Thanks for listening and have a great conference.